Cool. Hi, everybody. My name is Nicole Mazzuca. I'm a senior software engineer at Remarkable. I've done quite a lot of things related to package management and build systems, and I have a lot of opinions on how build systems work right now. And we're going to see how this talk goes. I've given it a few times, and I'm not great at this whole double thing, but we'll see. But yeah, so back at Microsoft in the US, I worked on this tool called VC Package. And in VC Package, it's a package manager for C++, right? Similar to like an NPM or a Cargo, but without the build system part. And as part of that, I wrote a lot of CMake code, because when you have a package management system in C++, you have to actually build your code somehow. And we generally do that with CMake. So, why are we talking about this? You all hopefully at least know CMake. You know of CMake. You've used it before. And you know how incredibly painful it is. But the underlying model is incredibly powerful and incredibly useful and kind of exactly what we need. And it also includes a lot out of the box, whether you're installing code or you're installing libraries. It works well inside of existing systems. This is kind of the big thing with CMake, that's as opposed to other build systems, is that it works really well with however your system works, it works well with. However, in other languages, we have this kind of stuff like Cargo. For example, if you've ever used Rust, if you've ever used Go, if you've ever used Swift, you know how easy it can be in other languages to write your build system. All you do as the developer is the build system gets out of the way, and you can write your code, which is what you care about, which is the Rust or the actual application. In C++, you need somebody to be the build system expert. Either you, in my case, I'm usually the build system expert, which makes me very sad. Or often you'll see something like you copy stuff from somewhere else. You find somebody who did this somewhat right somewhere, and it ends up kind of working for your case, and then you make minor modifications, but you don't really understand what's going on. This is very common in the CMake world. So I love this example of a comparison with Rust and Cargo. This is on the right-hand side, 4 lines, which does exactly the same thing as the left-hand side in CMake. This is just as installable as this side, but instead of 4 lines, you have, 30, 40, which is horrible. It doesn't need to be this way. And it is this way because of how CMake has evolved over time. But we should always be working towards better. If people have used CMake back in the CMake 2 era, it used to be a lot worse than this. And it's only gotten better over time, and we can make it better again and really work on the ergonomics of CMake. So I'm going to talk a little bit about what my work at Remarkable has been. So we have a large monorepo, builds with CMake. We have some larger internal dependencies that are managed with an internal VC package registry. But generally, we have a large CMake build system that is managed by the people on my team. It works okay, but there are some major problems. A lot of the problems have been related to kind of just much of the infrastructure that is available for free and in the open source world is designed for small teams doing smaller repos, and kind of working across repos to kind of build one product together rather than this large monorepo. Monorepos are fantastic when you have the resources of a Google and you're able to kind of have like 5 people, 10 people on staff to do all of the CI stuff and all of the monorepo stuff and all of the build system stuff. But when you're a smaller company like we are, it ends up being some person's side job to just get it to work when it breaks. So our current work has been pulling this big monorepo into smaller repos. We have kind of pulled out specific teams. So for example, we have the graphics stack, and the graphics stack has been pulled out into its own repository. And that means that the graphics team no longer needs to do this building of the entire world just to test their own small changes. And what I have been doing is building the systems to make this work well. And when we have these mini repos, right, we want the people who work on the repo themselves. We want the graphics team to be able to do their own build system stuff, and we just give them the tools to do it themselves. So how do we solve this? We have a reasonable enough package manager in VC package. We've had some problems with VC package, but they're solvable. We need to work on it, but the build system part is not easy. Getting your average C++ developer to write CMake is really not easy. And whether we can get them to write CMake or not, they probably will write the CMake, but it won't be correct. It'll be wrong 75% of the time. It might work in their small case, but then when you try and bring it all together into the main repo, you then have to go in and fix it. And if you ever look at the VC package repository, they have 1,200, 1,300 libraries in there. And I would say probably half of them, they've had to go in and fix the libraries underlying CMake because it's so difficult to write CMake correctly. So what have I been working on? This thing called Row. And so first of all, what we want to do is make it so it's easy for C++ developers to just build their code. All they should be caring about is the C++ code. The CMake code should be a secondary thing that they can just kind of spit out. This is an example of Scene is one of our internal graphics libraries. This is 87 lines of files that they have to manually update every single time. And then they add this library Scene private, and then there's much more stuff down the list, or down the CMake list.txt that they also had to do. And this is not even including stuff like installation, because this was part of the monorepo. With the new stuff, it's just a row add library. This is exactly how it looks in our current code. You have source, and that says, take your sources from source. You see that we actually do have a cute resource file. We would not have seen that in the 80 lines. And so this is part of what we're doing, is we're making it easy to just add a library. Let's see if this demo works. We're gonna do our best. So we've got our CMake list.txt. This is the entirety of the CMake. And no. Oop. Come on. There we go. So we build the thing. It takes 2 lines. It takes 5 lines of the actual code, right? Of the actual build system code. And all you care about is this row add library, the project mu, and then you can write your actual source files. You can write your includes. You get this that just works. So, and all you're doing is you're writing this include. And theoretically, the important thing is not row. It's that we could make this happen within CMake or within your own CMake library. But yeah, so that's all. And very cool is we implicitly do the right thing with regard to installation. If you've ever tried to install a CMake library, it is so hard to do it correctly. It is so difficult to do it all without forgetting a step. Basic package version file. I think there's also you have to do a package config file if you want to have a package config file. It's hellish to actually remember to do all of the things. I think if we go back, it's too many. This is how you install a single file library with one header. That's not okay. Anyways, so we have and when you're using something like row, this is all you have to do. Just row add library. If you have dependencies, you row find package for reasons, so you don't have to think about the find dependency stuff if you've ever written a CMake config file. And so if we look at the second demo, depends. Okay, cool. Come on. So we depend on mu. We link libraries against mu. This is all. It's done. If we build, it installs it via VC package. Oh, what? Okay, I screwed something up in my thing. There's some. How did I? Oh, one sec. I was doing tests earlier. Let's do this again, correctly this time. There we go. And if we look, right? If we look up here, come on. Look at our build. We have our lib, we have our include. It all works. It's so simple. It is 5 lines. And you didn't have to write any of them. Our developers don't have to write all of the installation code. It just does the right thing. So this is wonderful for, it makes it easy for non-build system people. It's easy to switch to and start greenfield projects in. Most people do not care about layout, so we do make some assumptions about the layout. If you care, we have some ways to kind of break out of these assumptions. And I want to be clear that options in the build system definition are generally mistakes. When you're the person writing the build system, you should not have a bunch of options on how to lay out your code, to be honest. You should get this is how we generally do things here at this company, for example. Now, this is as opposed to the person building the library. You can give them as many options as you want, and row does. But I wanted to show how easy it is to convert existing libraries. So we have, at Microsoft, I wrote these little example libraries that I always use for everything. And I think the coolest thing about them is just, let's see. We're gonna do our best. So we have this port file thing. I should do this backwards. I made mistakes. Okay, we're gonna do this in NVim actually. So, how do I get this to work? No, that's not gonna work? Okay. I gotta do some copying. So the important thing is that, that's not helpful. Why did I do this to myself? Why did I do a live demo? Okay. Okay, we're just going to ignore this for now. The important thing is that every single every single change is very small. If we look at the patch, we want to git log dash dash patch dash dash reverse A1 F95C. Yeah. Oh, whatever. Doesn't matter. But basically, if this worked well, you would get that we have taken this long piece of code and we go through really simple steps. Two. Okay. We add the row boot first. It's very easy. Then we next do a row add library. We're able to always only add what we need to add and avoid kind of making a bunch of unrelated changes. And this means that it's really easy to code review switches to row. When you want to use row's installation, you just delete a bunch of code. You delete the skip install, and then you just delete all of the installation code. If you want to then use the command line flags, it's super easy. All you do is, if we have some warnings that don't work, we disable the warnings. We set the row CXX standard to the right CXX standard. We row add library bytecode. We have taken what used to be 50 lines of CMake and turned it into the exact same project, except now it's 12, 13 lines of CMake. And this is the thing that I want us to see, is that we can actually make CMake ergonomic for normal developers to use. How does it work? We use existing patterns. We do not change how CMake works. We use target sources and source sets. We inject ourselves 3 different parts, and each of the parts works without the others. So this kind of row add library thing where you don't have to write all of the sources out manually, that's one part. You don't have to use it with the other 2 parts. The installation support that really should be, in my opinion, kind of the default for CMake, that is another part that we don't need to worry about. Then we also kind of put ourselves in at the beginning in the tool chain. So we download VC package, and we get the right compiler. We get the right standard library for this. We only do this when building from the command line because always we need to be thinking about when other people are using our code. We do not want to be making assumptions on how their system is set up. We want to give them all of the power to do whatever they want. And so we do this. We put ourselves as the tool chain, but we do not make the assumption that we're always going to be the tool chain. We take care of installation for you in an opinionated way, installs all your installed targets under your namespace, creates a default target that links everything. It just makes installation easy, and it works with existing systems. Really important that it works with existing systems. In the middle, we build. It's kind of the least interesting part of this. It's the most helpful for random C++ developers, but it doesn't do very much. It mostly just gives you it sets you up for success. As part of doing this at Remarkable, we've had some challenges. VC package is designed for packagers. The R is important there. It's designed for people who are taking other people's code and giving it on. So somebody like an apt or a deb or a RPM that is what VC package is for. It's not designed for our internal system. So we have had some problems with that. VC package versioning is extremely confusing. The dependencies of dependencies of dependencies. When you make a breaking change in a low-level dependency, everything breaks and it's horrible. So we're working on this as well. We are trying to figure out what is the best solution going forward with VC package, because we do want to continue using this kind of package management system, but we're not sure how best to do it. We've got some future enhancements coming for Rho. We want module support, but we need to figure out how we're going to do that anyways. That's quite a difficult process. We want better platform-specific file support, better support for non-VC package managers. The important thing with Rho is not Rho itself. The important thing is it's a proof of concept to get people to understand that there is a better way, that we can have normal C++ developers write CMake without dealing with the horribleness of actually writing CMake and dealing with other people's CMake code, which can often be very terrible. But the question is, like, how do we get this kind of ergonomics into CMake in a way that people actually want to use it, and that companies are willing to kind of switch to this system? Do we need people to just write their own rows? Do we need to upstream stuff into CMake? I'm not sure. It's really difficult to know, and I'm mostly putting this out there to say, like, what do we think we should be doing? What does the C++ community want to do with this? Because we know for now that writing C++ is really nice until you have to, like, build it or ship it to anybody else. And that seems like not the most difficult problem. You know, if you look at Rust, if you look at Cargo, if you look at Swift, we know that we can do this better. So how do we do it better? I do want to acknowledge Robert Schumacher. He has this fantastic talk called Don't Package Your Libraries, Write Packageable Libraries, which has kind of changed how I think about the world of programming. It is really about, don't try and control the world, control your small part and give other people a standard interface to you. The Cargo team has done an absolutely fantastic job. If you've ever used Cargo, it's one of the easiest things to use. You just Cargo new, and then you write your Rust code, and you don't have to think about anything. It's fantastic. You don't ever have to think about build systems until you're doing something with features, and then it's easy to do something with features. So I've gone way too fast on this talk. I'm sorry. I'm nervous and talking fast. But I want to give us a call to action, which is really, how do we get to the point where this kind of row-style situation is easy and useful for everybody? And I have a ton of time left, so I'm going to go into a little bit on how Rho actually works, because I'm actually quite proud of it. Anyways, let's see. We have this kind of, the initial way that Rho works, and I'm hoping that other companies take this and, like, use it. I will be open sourcing it, hopefully tomorrow. We'll see. But we have a Rho boot. Come on. And the Rho boot literally just, like, copies it into a Git repository. It's not important. It just gets it. The unfortunate thing with CMake is that it doesn't really have a good, before the project starts, method of getting stuff. So because we want to run before anything else, we do this kind of weird Rho boot thing. But We have a nice row boot update, which in our code anyways, we return in the OSS version. We make sure that you're up to date. We want to, if we go back, nope, that's the wrong one. No, where are you doing? Come on. Huh. Why are you not? Okay, well that works. So internally, we have row current major being a major version. When we make breaking changes to row, we pop this. And so if you are on an old version of row, you'll continue getting the older version of row, but we'll warn you and say, you should do a new version, which is quite cool, I think. What am I doing? Okay. We have Clang formats. We have, this is quite cool, actually. So this allows us to install config files into the user. And so if you install a library that uses row, you just get a config file that works. That's how this installation stuff works. Other than that, it's very simple. We just kind of have this row add target, which does a bunch of globs. Globs will not hurt you. They're wonderful. Use globs more. We have some cool helpers, row parse arguments, which actually gives us a nice interface to CMake parse arguments. And generally, it's about, I think, 1,500 lines of CMake code, and it gives you everything you could want from it, except for tests. So I think that's kind of all I wanted to talk about today. Are there any questions? That was the end of the talk, sorry. Yes?
Do you have examples of how to integrate test suites into these CMake files?
So that is the unfortunate thing. The question was about test suites. The unfortunate thing is I have not written the test stuff yet. This is a fairly new project, and the power of row is that it is just standard CMake, and so you just write normal CMake code to add tests. Hopefully there will be work to make it nice to add tests, and there are certainly ways to do it. I just haven't done that work yet. And you can always just use normal CMake, right? That's kind of the benefit of this situation, is that you can always use regular CMake.
I'm just wondering about, let's say, the source file protection.
Yeah.
So at work we have this big monorepo.
Yeah.
But sometimes with some application, we should select basically which file is to be written. We should just take everything inside. Is there any way to tell the row, okay, I want to have everything but those ones, or just kind of select?
Yeah. Actually, I don't think it's in any of my examples, but basically what you end up doing, where are we? Yeah, is something that looks like this. And what ends up happening is it takes everything but blah.c. I'm hoping there are certainly ways to do this in a nicer way. So in XOSTD is our kind of remarkable standard library. We have Windows stuff, and we have stack trace stuff that, oh, my phone is going off. Can you, it's apparently 3:30. I don't know why I have an alarm at 3:30. So hopefully we can get to the point where we have this kind of, this is only on Windows. This is only when this feature is set. But as of now, it's not really a thing. Something I didn't actually talk about, something cool that we do for internal libraries, we have internal libraries that have features. And so if you have a feature in your, where are you? in your vcpackage.json, if you have these VC package features. Oh. Do I have the wrong keyboard set up? Is that why I'm? Oh, that's why. Okay. Turns out I got switched back to the US keyboard. This is why my my keyboard shortcuts were not working. Anyways, but if you have, like, for example, a test feature, which does stuff, not important, we will set build testing only if this feature is set, and similarly we'll only install dependencies from the test feature if you have build testing set. Similarly with dev, I think, if you're in enabled dev mode, then you'll get those dependencies, and any other features just kind of get mapped to feature _ stack trace, for example. And we use this for our standard library. We have stack traces or not stack traces, depending on if you want stack traces or not. And we only install dependencies, CPP trace, I think, and we only link against CPP trace if stack traces are enabled. Yeah. Any other questions?
Yeah. So basically started doing the same work. I'm just a tenth of what you have achieved. So I wanted to ask, like, have you handled cases like, I don't know, header-only libraries when you do add library? Because that's very nice.
Yeah. Yeah.
Developer perspective, but then there's these little custom cases you need to take care of.
So thankfully, yeah. What you do, like literally all you do in order to have a header-only library, like let's say that our Baycode is a header-only library. Let's just pretend. Then all you do. Oh, that's not the right one. All right, it's now a header-only library. It works. Then basically what we do is we just check for a source directory, and if there's a source directory, we add it. If there's not, there's only an include directory. We still install the include directory as a normal header-only library. Yeah. Also, I do want to say this about the row CXX standard. In CMake, you have two kind of concepts. You have the C++ standard that you need to build your library, and the C++ standard that you allow your consumers to have. So you might require C++ 20 in order to build your shared objects, but you only need your clients to have C++ 11. You can set these distinctly. The row disabled GNU warning flags, similarly to the row disabled MSVC warning flags, are if your code doesn't yet build without any warnings, you could disable them. And I like that a lot. Any other questions? Yeah.
So I don't have knowledge making CMake and knows of it.
Yeah.
You said at the start that CMake has so many useful concepts out of it that isn't just getting away.
Yeah.
Can you formulate what those concepts are? Like, I'm just curious.
Yeah. Yeah, so I think the first thing that CMake has done right is in comparison to everything else out in the world. And not necessarily everything else out in the world. I think Mason also gets a lot of this stuff right. But in comparison to Make or whatever. What CMake gets right is it has a very strong separation between my code and your code, right? And so you end up using these things called find package to get other people's code. And importantly, this row find pack, or just regular find package, it's the same. It doesn't care what Baycode is built with. You know, you could be using MS-Build to build Baycode. You could hand assemble Baycode. It doesn't matter. The important thing is that it just exists on your system. Doesn't matter how you get it, and it's there. So that's something that CMake gets really right. It does not need to be the whole system. It is only a part of the system. And from the actual building perspective, you have these really nice things, targets. And a target is like a library, kind of the concept of a library. And then inside a target, you have sources, and you have include directories, and you have all of this stuff, and include files, and you have all of this stuff kind of packaged together in this nice way. And you have a lot of control over different targets, and it allows you to kind of, as a person writing stuff, you have a lot of control, and there's a lot less that's implicit, as opposed to something like a make, for example. And I think that kind of explicitness really helps with CMake. It is what makes it more verbose. That is the problem with CMake. And I would argue that basically CMake is this really nice, powerful beast. It's similar to C++, right? You want this kind of powerful beast, but then you want to like build on top of it to give people a nice interface into the beast. And I think that's a really great thing that Rust does, for example, is that they have this huge beast of power, and you can do whatever you want, basically. But they give you this really nice interface, so when you're actually writing Rust, you don't even think about all of the things that are going on under the scenes. Yeah. I think you got first. Yeah.
So where do you find the open source version?
It will eventually be at remarkable/row-oss, github.com/remarkable/row-oss. Yeah. I will. Let me write it down. It'll be at. Where's my cursor? No. This is where it will be. Yeah. Yeah, I will try and put it up tomorrow. It's been a busy week. I have not done what I should have done last weekend. What was your question?
I'm trying to do something similar, so I'm going to ask you a question that I was asking myself.
Yeah.
Not Bazel or back or something like that.
Yeah, so I don't have strong opinions on Buck. I've never really used it. My understanding with Bazel, at least, and similarly with the Google one. Is it Bazel? Okay, yeah. The problems that I have with Bazel are problems that I have from being a packager, right? I used to work on VC Package, and I had to build TensorFlow. And Bazel assumes that it controls your computer, basically. It puts stuff in random places. We had this horrible experience. Actually, this was Chromium's build system, but we had this horrible experience where if you ran a build in CI on Mac OS, the first time it would fail and the second time it would succeed because it put cache files in a random place somewhere. And so it was flaky, but it would just work. Like if you reran it, it would just work. And this is the kind of thing that I absolutely hate. Like I don't want my build system to pretend like it owns the system, basically. That's why I really do not like Bazel. CMake treats itself as it's a part of a whole. Yeah. If you have a monorepo, Bazel can be a really good option, I think. But you have to be willing to be the Bazel person, and you have to have like engineers on staff who are going to like work on that build system specifically. Is kind of my feeling about it. But I also have serious Stockholm syndrome for CMake, so. I have written far too much of this stuff. Any other questions?
Why reroll? Where is it come from?
So remarkable starts with an R, and I was like, it would be fun to like have RM or something as our build system thing. And then I was like, I like the Greek letter rho. It's a pretty letter, you know. not a good reason, but yeah. Yeah. Any other questions? Yeah.
You're saying more about why you're moving from monorepo, because I come from we have literally hundreds of repos.
Yeah.
I think monorepo sounds fantastic.
That's fair. I think there is somewhere in between. So the question was, why are we moving from a monorepo to a multi-repo? And I think, and specifically that they have hundreds of repos, and a monorepo sounds fantastic. I think that there is a nice middle ground in between hundreds of repos and a monorepo. I think, unfortunately, Remarkable never really tried a true monorepo. I think if we actually had like a monorepo that worked that way, it would be fine. But we end up having teams that are in their own repos, and so we kind of have this bad mixture of the two. And so we're trying to move towards more explicit, like if you're a team and you own a thing, you actually own the thing. We don't want to like have to build the world and download the world in order to work on the graphics stack, for example. The other thing is when you have, it's less of a monorepo and more of a single application repo, right? And so we have this one application that builds and runs on, this laptop, and my Remarkable is in the back of the room and on phones. And so what ends up happening is you have kind of, because we only have a single application and we can only have a single application by our architecture, when we want to do something more interesting outside of that, we have real problems with doing that. So for example, our web client can't use the rendering code in the application repo because that doesn't work. And so that's kind of why we're moving towards a multiple repos. Anyways, does that kind of make sense? Hopefully. Yeah. Exactly. Yeah. And there's definitely arguments about whether it's better or worse. I think we're trying to kind of have a more open source, kind of everybody is working on their own stuff, and then we can bring it together to be good thing. I hope it works. We'll see. We'll see the experiment. Come back next year. I'll tell you if it worked. Yeah.
So, are you familiar with Konan and the Konan generators?
Yes.
Yeah, so how do you think this compares to that?
My experience with Konan is that it is incredibly difficult to use. I have never used Konan and come away from it thinking, this is going to make my life easier. No offense to JFrog. I'm sure that if you know what you're doing, it can be really good. But it has been very painful every time I've tried to use it. And what we want is to make our employees' lives nice and easy. And all they have to do is write CMake --preset host --build. Right? That's what we want. And Konan does not feel like it has that kind of thing going for it. I might be wrong. Very possible I'm wrong, but that was my feeling about it every time I use Konan. But hopefully we also support Konan, if we feel like VC package is not ideal. Part of this row stuff is so that we can very easily switch over to a different project or a different manager.
We use Konan where I work, and I feel like it kind of solves the same problems that this probably does. But I might be wrong, and maybe it's different.
Yeah, it's possible. I'd be interested to talk. I really don't know anything about that stuff specifically. But yeah, any other questions? Cool. Then I think that's it. Thank you for giving me all the questions. I really appreciated it. Thank you for listening. Yeah.